Let's build a dissolve effect for our 3D objects. Hello, in this video we'll learn how to make objects appear or disappear with this awesome effect. This is an effect I saw on Twitter. Originally it impacts some part of the mesh, but I adapted it for the full object. It uses shaders, it's a great way to practice, and we will discover two nice libraries. But if you are still beginning and afraid of shaders, you can just copy the code of the material we will create and learn how to use it in your projects. Let's start by getting the starter project from my GitHub repository. Go to code and copy the HTTPS URL address. In Visual Studio Code, run git clone, paste the address. I'm adding a folder name, but you can just keep this part. R3F objects dissolve. Once it's done, open the folder, file, open folder, run yarn to install the dependencies, and yarn dev to start the development server. Click on the link to open it. You should see a cube you can rotate around. Let's change some default settings. Go to app.jsx, move the camera a bit on the back, increase the field of view. Go to experience, we replace the box geometry, it should be geometry, not buffer geometry now, and mesh standard material with a white color. Okay, we will add some default lighting with the environment component, with the preset sunset, and add some contact shadows. We'll position a bit below our scene. So far, this is what we have. This is the example project we are working from. We have the Stormtrooper model. We have that pivot control that affects the dissolve effect. So it's calculated based on the position of this control and the dissolve effect. Let's look how it works. We have here the app. We have the model. The model is just below. It contains the different meshes. We have one main skin mesh with a dissolve material applied to it. And dissolve material is the only component that we want to take into our project. For now, let's take it as is. Create a new component. In components, new file, DissolveMaterial.jsx, and paste it. We just want to make it work. Let's look at the library that we don't have yet. There is GL noise. And GL noise, what it is simply a collection of GLSL noise functions. If we look at what we use in this component, it's patch shaders. What it does is we pass a shader to it, and then we will have access to the different function for noise function inside our shader code. Let's add it to our project. Yarn add GL noise. Then the second component is 3 custom shader material. So this library, what it does is it allows us extend Three.js materials with our own shaders. By the way, if you are not familiar with shaders, I made 2 videos in the past that you can watch, and I recommend you before doing this tutorial. As always, the links are in the description. When we created shaders in the past, we made them from scratch, so we needed to write the whole logic. But here with custom shader material, we can pass an option-based material, so it will take all the logic, and what we can do is impact the vertex and fragment shader instead of recoding it. It will be maybe clearer when we will use it. Let's install it, yarn add and paste. So for now, before trying to understand the code and modify anything, let's try just to use it. We go to experience. Instead of the mesh standard material, we will use the dissolve material we just created. We need to pass the base material, so we need to create one. Let's create const box material equal new 3.mesh standard material with a white color. We need to import 3. Okay, and pass it to the base material, box material. We can see it's working. We have orbit controls fighting with pivot control, but still it's almost usable and we will get rid of it. So it's not a big deal. And you can see if we move it, the effect changes and apply to the cube. But this is not the effect we are going into. We don't want it to be based on a point. We want to dissolve the entire mesh and to make it appear again. Let's go to DissolveMaterial. And let's start by trying to understand what is happening. We have the DissolveMaterial defined here. There are some props, base material. There is mode, we can see it's unused, so we can just get rid of it. Thickness, feather, color, and intensity. Okay, color is the color of the dissolve effect, the border. Intensity, we'll talk about it later. We have a use effect which applies the props of the dissolve material into the uniforms. The uniforms are variables that are passed to the fragment shader. Then if we look into our component, what it returns is a CSM, so it's custom shader material from the library we installed, 3 custom shader material. What it takes is base material, the shaders, the uniform, tone mapped false, and transparent, okay? And the pivot controls, which is this component here from Drei, and it impacts a uniform, so it's the point to change the dissolve effect. So basically, the component structure is quite easy. It's only this custom shader material. So the main of the logic is into the shader. Let's try to simplify it. We will remove everything that is related to the box and the point. We know we don't want that pivot control, so we remove it, and it's affecting the uniform U matrix, so we won't need the U matrix too. But just remove it for now, and let's go to the shader. So the shader, we have the fragment shader and the vertex shader. Remember, previous video I showed that the color syntax is correct because of GLSL and an extension I use. The extension is here, extension, it's comment tagged templates. You need to install that extension, so when you do that comment GLSL before, it correctly colorize it. Okay, so let's start by the vertex shader. It contains a custom VUV. I will just rename it to VUV. It also contains a V position, VBox UV, UBox min, UBox max. But all those varying and uniforms are box related, so we can get rid of them. And we will just keep the VUV. So our fragment shader code is very easy. It's just to get the UV passed to the fragment shader. You can notice the difference with shader we were used to do, and this one is we don't put the code because it's already in the base material. So we are just using it to pass the VUV. And we don't need to code the default logic of the vertex and fragment shader. Okay, so the big thing is in the fragment shader because we only have one line in the vertex shader. We renamed custom VUV to VUV. We removed those varying, so we removed them here. The U matrix, we know we don't need it. The U feather, what is it used for? It's used with the distance and SDF box, so it's box related too. We can get rid of it. The U thickness, it's used for the border size, so we need to keep it. The U ramp, if we search for it, it's not used, so it's just a ghost variable. We can get rid of it. And the U color is the color of the border, so we can keep it. Then we have two functions, but they are related to the SDF box. We can see transform is also using the custom view position, so we can get rid of those two functions. Then we have the main function and the logic of our shader code. You can already see that it's few lines of code, so don't be too scared. The 3 first lines, what it is about, it's about generating noise. We don't use any more custom V position. We need to use our VUV to generate the noise. What is this scary line? It's just from the GL noise library. And you can see it's the default option to generate some noise. So all of this is to generate our noise. You can go further by reading the doc and playing with the parameters, but we know like this, it works. Then we have those two lines, which were based on the fact that we have a point and we calculate the distance, but we don't use it anymore, so we can just get rid of those two lines. Okay, so now we have progress equal distance, but we don't have distance anymore. We will use 0.5 for the moment, but we will need to use a variable. Then we have the alpha, which is based on the progression, because progress will be between 0 and 1, and the noise. And based on that, we will have a value between 1 and 0. Well, it's not between, it's either 1 or 0 because of step. Then the same logic applies for the border, but it's using also the hue thickness and the alpha to calculate that it's a border across the texture. And then you had the logic, and now it just applied into the fragment shader. So the alpha is applied with alpha plus border, and the color, it's either the original color of the material or the hue color, which is the variable we pass into, which is for the border, because it's a mix between those two values. Let's see so far what we have with our simplified version of this shader. If we look at it, we can see our cube is halfway dissolved. If we increase it like 0.75, it's almost complete, while if we put a lower value, it's almost entirely dissolved. So what we will need to do is to animate the progress. We need a variable to store it. So we create a new uniform. It will be a float because we want a value between 0 and 1, which we will name uProgress. And here our progress, it will equal the uProgress, which means that we need to add it to uniform. uProgress value will set to 0 by default, because by default it's invisible. By the way, we can see here we have a 3 object that is useless, so we can get rid of it. Do we still have uniform that we don't use? We have uMatrix, we don't use it. uFeather, we haven't, no, we removed it, so yes, we can get rid of it. The thickness is the thickness of the border, we keep it. The uColor also. We will explain multiplies color later. And we are fine. Here, base material, we keep it. Thickness, feather, we said we get rid of it. We can get rid of it too. Okay, so now what we need to do is also to get rid of uFeather here, remove it from the use effect, and we will need to animate the uniform's uProgress. We will use a use frame for it. And we will use the easing functions from Maath Library. So let's add Maath Library. Yarn add Maath with 2a. Okay, yarn dev. And easing from math.demp. Then the object we want to apply it to, so it's uniforms.uProgress. Then the key of that object, which is value. Then the target value we want, which is 1. The duration we want, so we can make a variable of it. Let's add it duration. Let's make it by default, it will be 1.2. Here we can now use duration, and then the delta. So delta, the delta, we get it from useFrame. So it's not the first one, it's the second parameter from the callback. We save. Now if we reload, our objects smoothly appear. But we also want to be able to make it disappear. So we can add a visible prop, which will be true by default. And the value in the easing will be not 1, but it will be, is it visible? If it's the case 1, either it's 0. Now we need to control it. So we go to experience. We will need some control. So we will use leva to go faster. Yarn add leva. Okay, yarn dev. Let's close it. Const item displayed equal use controls. The value by default will be box. And we'll set different options. We'll have a box and a sphere for the moment. Okay, so is our box visible? It will depend on item display equal box. Oh, by the way, here it's item displayed, it's an object. Here it is. Okay, so here I can switch to sphere. We don't have a sphere, but now it's not visible anymore. It's dissolved. And we can switch back to box and it reappears. Okay, now let's add a sphere. We can copy paste, add sphere geometry, use the same material for now just to show you what will happen, and visible will be item displayed equals sphere. But here, because we are using the same material, both are halfway because they are fighting each other. Let's create a separate material for the sphere. So copy paste sphere material and use it on the sphere. But if we reload, we have the same issue. This is because in our DissolveMaterial, the uniforms are set on top of the component. So it's global to every DissolveMaterial. We'll need to move them inside DissolveMaterial and use ref. So it will be persistent between reloads and it will be unique for each DissolveMaterial. The only thing that the fact that we use ref change is the fact that now it's not uniforms, but it will be uniforms.current everywhere we use it. So here, 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 and also here. Now let's see what we have. If we are on box, we still have only the box, but we can see the shadow of the sphere, which is normal. It's because the material is invisible, but the shadows we are using are based on the mesh itself, not the material. So the sphere exists. And if we switch to sphere, we can see it appears, but it's too big. Let's make it half scale. Now go experience mesh scale equals 0.5. But now if I'm on the sphere, I can't see it. It's because the box is hiding the sphere, so it's not even trying to display it. But we want to transition from one item to another. So once the item is dissolved, we should hide the mesh so we don't have issue with the shadows or with the display of the other item. For that, we will create a state that we will name visible item equal use state. And by default, it will be item displayed, which by default is box. But if you want to change it, you just change it here and not at two places. And we will also add a callback function to our DissolveMaterial when the fade out is done. So we will create a function on fade out. And what it will do is just set visible item to item displayed. So visible item will impact the visibility of the mesh, the rendering of the mesh, while item displayed will impact if the value of the progression of the DissolveMaterial. So let's wrap our component and add the conditions. So here we display this mesh only if visible item is box. And here, if visible item is sphere, then we render this mesh. And on the DissolveMaterial, we'll add the onFadeOut callback. Now we can go to DissolveMaterial, add onFadeOut, which is our callback. We don't need a default value. And in the use frame, we can do if uniforms.uProgressValue is equal to 0, and we have onFadeOut so it's not undefined. Then we call onFadeOut. Let's try it. We have our box. Let's switch to sphere. So it dissolves. Here it's long, and then it switched to sphere. Why it's long? It's because when the value is very close to 0, so 0.00 something, we still have not called the callback. So maybe we can try if value is below 0.1, then we call the callback. Let's see if it's faster this way and gives a better effect. Okay, now it smoothly changes from one to another. Okay, now let's play a bit with the color. We didn't change them, so we can go to experience and define a color for the border. For the box, I'll be using this one. And for the sphere, I'll be using this one, which is here a blue and here a green. So let's switch. We have the blue and then the green. To make it look better, we can add some post-processing effect to our whole scene. Let's add the package required, yarn add at React 3/post-processing. Okay, in Canvas, we add an effect composer from React 3 post-processing and add some bloom with luminance threshold. So it's when the value of the color is over this, it will start blooming. So we set it to 1, which is pure white. So we will go over the white to make it appear. And intensity of the bloom, I set 1.25. If we try it, the effect is a bit weird. To make it work nicely, we need to add mip-map blur. I can tell exactly what it does, but it helps fix the issue. If we change, now the bloom effect is really bloomy. I say that we need our color to be beyond 1 on the R, G, or B to start blooming. And we didn't set color here that should bloom. But it happens because on DissolveMaterial, we have here the intensity, which is by default set to 50. And well, it's not used. Oh, yes, it's used. It's used below. Okay, so here we set the color, and after we call multiply scalar by the intensity, which is increasing the intensity of the color, and then it reaches above the one on the R, G, or B channels. So it starts blooming after that. Let's try to add those effects on some models. So let's search for table on the Powerman market. I will use this table because it only has one material, so it's easier to install it quickly. React 3 fiber, copy JSX scene graph. That way we don't need to download the model. Go to components, create table.jsx, paste it. So it's using the CDN models, but you can also download them if you prefer. Export function table. I prefer to name my component. Also, it's up to you. Let's create also a chair. Let's search for the chair. This one is from the same creator. React 3 fiber, copy JSX scene graph, and paste it. We can same here, function chair, and we are good to go. Okay, now it will be quite fast. Just let's try our component. So experience, we'll add the table and the chair. We'll add visible item equal table. Then we'll display the table. And if we have the chair, we'll display the chair. So let's switch to table. Okay, it's a bit too high. We will decrease the Y position. But if we switch to chair, it won't work because we don't have the callback. We need to reload and to switch to chair from one component that has the callback. And we have an issue with the geometry. So this is something that happened with the market. Sometimes it has some cache, so it's not the correct JSX scene graph, but it's the one from the previous I did. Okay, so here you can see it's 0.74. If I paste it again, it's 52. So we can see it changed something. Export function chair. So we had an issue. Okay, and now we have the chair displayed. Let's change the Y position. I think it's -1 for both. Let's check it. Yes, it's on the floor. Perfect. The last step is to add the visible and the on fade out. So let's add visible equal to item displayed equal table. But we can't use visible because if you look at table, it will pass visible to this group and it will hide it, and it's not what we want. We just want it to pass it to the dissolve material. So instead we will name it dissolve visible to be specific, but we can have on fade out equal on fade out. Okay, we'll do the same for the chair, and it's chair. Now we'll just need in our table to replace here the material with the dissolve material. So we need to close the mesh to be able to add a dissolve material here. The base material is the material that we are currently using, which is this one. And we remove it from here. We need to pass visible. It's from the props. We say dissolve visible. And on fade out, which is on fade out. Okay, we can copy it and do the same on the chair. Don't forget to import it and use the correct material. Oh, but it's props.onFadeOut or it will crash. So here, props on fade out. Let's try it. Table and chair. For a better effect, we can change the color for the dissolve to something brownish that will fit better the existing material. Thank you for watching, I hope you enjoyed this video. If it's the case, please hit the like button to help the channel be more visible to other creative developers. A special big thanks to all of you, we reached 10,000 subscribers this Sunday, it's awesome. Let me know in the comments what you'd like me to cover in the next videos. In the meantime, continue your learning journey and jump to the next tutorial by clicking here.